Happy day, calculus people. Are you having fun with Riemann sum? I just thought of that right now. Let's take a look at where we've been since we've been held captive in our homes. We have done antiderivatives, which is another name for an integral. We only dealt with some polynomial and some trig, very basic. You just got done approximating areas between a curve and the x-axis using Riemann and trapezoidal sums. You did look at graphs and you looked at tables. And today I'll go over a couple things here I wanted to point out. One of those is I didn't pay attention to the problem, and our answers were too large, because I'll show you why. But today, we're not estimating. We're actually going to use the first fundamental theorem of calculus, which implies there's a second. Yes, that's right, there is a second fundamental theorem of calculus. Too bad we waited for over half a year to get to the fundamental theorems. Anyway, let's look ahead, what we're going to go. I don't see where they've posted a quiz in here, but I know there is a quiz, and if I'd have to say it's somewhere in here, but I don't see it listed in here. He did list his test at the end. Okay, let's get started. So what I'm going to do, I'm going to stop right there and I'm going to highlight where we're at. We are right here. Oh, that's not highlighting. This will be highlighting. I hope. That's where we are today. And I'm going to let you go. So, adios. Oh, let me write the name up here. We are using the first fundamental theorem of calculus. Boom. Bye. I wanted to talk about. I gave you a copy of this yesterday, all completed, of the author's estimated. And some of my answers were off. And thank God to people out there like Yasmin and Shiza and Mia and Catherine. Who else? Chantel. They found all the little tiny things that were inaccurate. So thank you very much, and keep it coming. It's a lot different doing it without anybody stopping me at the moment, you know. I'm used to a couple of you throwing your sandals at me to stop me, but it doesn't happen here once I get on a roll. This was the last page of this chart here he was asking you. At this point, place a star next to the approximation that you feel is more accurate. Okay. Now you were supposed to take a guess. I think I even gave you probably what the author said was. I didn't erase the star. But in this next lesson, we're going to learn how to find the exact area of a region. The exact area. Well, you already sort of know, because it's the integral from a to b of that function, and we are able to do the antiderivative of this. And actually what I should do is call this a small f. Because what happens is you're going to do the antiderivative like of any other polynomial. We'll call that big F. And what we do is we plug in the top number into that. Then we take that same antiderivative, we go subtract, we plug in the bottom number. And that gives us the exact answer. And I don't know if... Oh, I still have the function there. So we were dealing with this function. Make it a little bigger. Let me put it over here. It was a negative 1/3 x squared plus 2x plus 5. And it was an upside down parabola. So let's do that work and see what we were going at. We were doing 1 to 7, as I recall. We were doing 1 to 7. 1 was here. 7 was out in here. We were finding that. And you found it with a lot of rectangles. And even trapezoids, I think, was in there. Yeah, I can see right now. He said we had 2 trapezoids. 2 units was the height of the trapezoid, and then we did 1 unit. We did midpoints, we did left-handed, we did right-handed. Hopefully, there really needs to be a quiz after this lesson. So I'm going to say it right out loud here. I'm going to say there's got to be a quiz, whether it's an AP-style quiz or I just throw out 4 problems and have you do them within, like 30, 35-minute block. And what I'll do is I'll let you know roughly when it's going to be posted and when I need to have the answers. Got to put some sort of integrity to it. Speaking of integrity, I re-looked at the submissions of second period and third period, and it didn't look like any class had everybody submit, but in looking over, there were people who submitted the copy of their test but didn't put in the answers into the Google form. So that's why it didn't look like I didn't have a class. 2A did have complete submissions. I will double check that. But it looked like everybody submitted. Not everybody in 3 submitted. All right. So I have my function. My f of x is the negative 1/3 x squared plus 2x plus 5. And if we are looking at the interval from 1 to 7, then we will integrate the negative 1/3 x squared plus 2x plus 5 dx from 1 to 7. That's how we put it. This becomes a definite integral because we will actually have the answer. So if I do the antiderivative of this using the reverse power rule, meaning I add 1 to this power, making that a 3, then I divide by the 3, but remember I already had a negative 1/3 in front of it, so that becomes a 9 in the bottom, plus that power of a 1 becomes a 2, so 2x squared divided by the 2, plus this has an x to the 0 power. 5 times x to the 0 is still a 5, so that becomes a 5x to the first power. Now we used to go plus c, but we don't anymore. We say equals to, and let me simplify that before I go on to the next step. I'm going to write that as a negative x cubed over 9 plus x squared plus 5x. So now what we say here is, what I didn't write down, I should have wrote down, is that if we're doing the limits now, we put a vertical bar after you've done the antiderivative. And you say, I'm evaluating that from 1 to 7. Even this simplified part is from 1 to 7. All right, so let me change my pen. So now I'm going to plug in the top number. That's what we do. We plug in the top number first. So I'm just going to look at over here and plug in the top number. Top number goes first, then I will subtract, plugging in the bottom number. Plugging in the top number first, I get a negative 7 cubed over 9 plus 7 squared plus 7 times 5 is 35 minus, now plug in the bottom number, the 1, negative 1 cubed is 1, 9, plus 1 squared is 1, plus 5 times 1 is 5. Now, if you know your times tables, sometimes I don't know, so I'd have to do 7 times 7 is 49, 49 times 7, and realize that was a negative. 28, 9, 30, 343. 343 ninths plus 49 plus 35. Wait, did I lose something? That was x squared over, no, wait, that was just x squared. That works out good. All of that minus, let's do this math. 5 plus 1 is 6. So I got a negative 1/9 plus the 6, which is a negative 1/9. Multiply that by 9 over 9, 54 ninths. Negative 1/9. Why am I missing a number? Yeah, negative 1/9 plus 54 ninths. That's easy. That's 53 ninths. If I'm not mistaken. All right, and come back to the left. Now, 343 doesn't divide by 9 because it was a 49 times 7, and neither of those divides by 9. So I'm going to have to take the 49 and turn that into something over 9. So 49 times 9 over 9, we'll rename that. So 49 times 9, that's an 81. 9 times 4, 36, plus 8, 44. 441. Let me do that math again. 81, 36, 40, I think it's 441 ninths. And it's negative, remember here. It's going to be, I'm sorry, that's positive. So, wait, why did I combine those first? Negative 343 over 9 plus 40, 50, 60, 70, 79, 84 minus, and double checking this again, making sure that that number is right. I plugged in the 1, negative 1/9, plus the 1 plus the 5, that's a 6. And the 6 is 54 ninths. I think it's still good. 53 ninths. All right, 84 does not divide by 9, but I can try to convert it. 84 times 9 over 9. 80, what did I write 3? 84 times 9 over 9. Negative 343 over 9 plus, so 84 times 9, 36, 72, 75756 over 9 minus 53 over 9. 756 minus 343 is 3, 1, 4, 413. And it's positive. 413 ninths minus 53 ninths. And so 413 minus 53, 0. 41 minus 5 is 36. Is 360 over 9, which is 40 exactly. Now, that does look very close to several of those answers. That would be the exact answer. That the true answer underneath that curve was 40. This was using the first fundamental theorem of calculus. I just did the whole lesson already because working this out in this detail all by hand, and the answer is so close to those estimations, what's the odds that it would come out exactly to a whole number? It has to be correct. Back here, the best estimation close to 40 probably had more, either had more rectangles or it was a trapezoid. I'm just throwing that out. You can tell me if I'm right or wrong. But 3, there were some tables that we were looking at, and as I recall, probably every one of my answers are wrong because I didn't pay attention to my limits. This only went from 0 to 25. So, well, no, this one was probably right. Midpoint, 3 intervals. I don't know if I did it right. Let's see if I use these 3. There's my midpoint. Perfect. If I now used, you always got to piggyback off of an end here. These 3, then here's my midpoint. Piggyback off of this end here. Those 3, that's my endpoint, midpoint. And so if that's what I was supposed to do, then this integral from 0 to 25 of f of x dx would be approximately, now let me show you a picture of what's happening, at least at the beginning. My ordered pair was 0, 15. So 0, I'll go up here to 15. Next was 4, 6. 4, 6. The next one is 7, negative 5. 7 down here. So if this was a smooth curve, and that's that first part, think about those 3 points. We are actually creating 3 rectangles, and the interval was from 0 to 7. The height is the one at the 4 because it's in the middle of it. So 4 was here. So we have to draw out to the right and out to the left. That's That's my rectangle I'm using. You say, well, that's kind of small. Well, yeah, because I had some negative area on the bottom here. This is all negative area. This right here is all negative area. This is positive area. So there's more positive than negative, so it does seem to work okay. If you look at the next, the one in green, starting at 7, -3, the next part was 12, -10. So I'm over here 12, and I'm even farther down, -10. And then 15, -2, 15, -2. So it's about here. So if this is still a smooth curve, just doing something like this, and that's all negative area, all of that. So I find the middle, which was at the 12, and you go to the function at that middle here, and we go out, right, and left, and that's the area we're getting, all negative area. And the last piece started at 15, -2, went to 20, way out here to 20, and it went up to 8. So it's about here. Then it went to 25, up to 20, which is even taller than that. So here's a smooth curve, now doing something like that. And so you can see that now almost all that area, right? This is still negative area right here. But after that, it's positive area. The middle is at the 20. So I go up to the 20 on the function, go half of that interval to the left, half that interval to the right. And those are my 3 rectangles that I'm adding up. So I'm not going to draw that again, but this is the visual. So that first rectangle, the width went from 0 to 7. I can't see my writing anymore. 7. So that width is 7. So if I do my areas approximately, the width is 7 times the length plus the other width times the other length plus the other width, that length, and they're all different in this case. The first width was 7. The length is f of 7. F of 7 is 6. So that's 42. So this first rectangle that I'm using is 42 units. The second rectangle is a width from 7 to 15. So that means this width is 8. So that's plus 8. But the height is f of 7. I'm sorry, f of 12. F of 12, which is down here at -10. So it's 8 times -10. So that's a -80. This area here is -80. Obviously, -80 plus 42 means there's more negative right now. Plus, the next width started at 15 and ends at 25. So that's a width of 10. And the height of that rectangle was at the middle. So it was f of the 20, which is 8. So that's 8, which is 80. Overall, you add that up, 80 plus 42 is 122. 122 minus 80 is 42. So overall, there's more positive area represented by this estimation Now, let's be honest. 3 rectangles is a poor estimation. If you looked at your other chart that we had, probably didn't cut it. Not for rectangles. All right, now what did I don't know. I don't remember doing that the other day. B wanted a left-handed Riemann sum, so left-handed rectangles, but it's only going from 0 to 15 with 5 subintervals. So I'm not even using this piece here. He's only going from 0 to 15, dividing it into 5 using left. So my guess would be, let's see if this works. If these two go together, and then these two go together, then these two go together, then these two go together. That's 1, 2, 3. See, 1, 2, 3, 4. Yeah, 4. Let's say I only got 4. And so the left of each of these, I'll star them. That's the left of this one. This is the left of this one in blue. This is the left of this one, the green. And this one is the left in the yellow. So there's your left. I'm not drawing it. I'm just going to say my integral from 0 to 15 of f of x dx is approximately, the width went from 0 to 4, so that's a 4, and the length is f of 0. F of 0, because that's the left. Now the blue went from 4 to 7, so that's a 3, and the left is f of 4. That will be its length. The green, 7 to 12 is 5. F of 7, because that's the left of that rectangle, plus 12 to 15 is a 3. The left side is f of 12. Plug it all in. F of 0 was 4 times 15. That's a 60. F of 4 is a 6. 3 times 6, that's an 18. Plus f of 7 is a negative 5. And so 5 times a negative 5 is a negative 25. Plus the yellow is f of 12 is a negative 10. So that's 3 times a negative 10. That gives me a plus negative 30. Is approximately 60 plus 18 is 78. 25 plus 30 is a negative 55. So I'm looking at whatever 78 minus 55 is. 325. That'd be a negative 25. C went from 4 to 20. So I'm not even using this one. And I'm not even using this one. I'm only going 4 to 20. And he wants 4 subintervals again. Well, this is 1, 2, 3, 4, 5 pieces. 1, 2, 3, 4. It's the same thing. Here's one rectangle. So my area will be approximately 4 to 7 is a 3 times f of, he wants the right. That means this is the right one. F of 7 is a negative 5. Plus the next two, they overlap, and the right one is this one. So 7 to 12 was 5, and f of 12 is a negative 10. The next one uses those two, and the right side is that side. So 12 to 15 is 3 times f of 15, which is a negative 2, plus the last 2, that gives me the 4 rectangles. 15 to 20 is a 4, and f of 20, because that's the right side, is a negative 8. Putting that all together, we get negative 15, negative 50, negative 6, negative 40. They're all equal negatives. 65, 105, 111, I think. And graph all those points. They're almost all underneath the x-axis. These three are. This one's not. This one's not. But these are this big. This 10 really. That 5 is just almost the same. These two almost cancel out, so it makes sense. The last one was the trapezoidals, with 3 only going from 0 to 25. Oh, I'm doing it all. 3 trapezoids. Now to do trapezoids, 3, and there's 1, 2, 3, 4, 5, 6, 7. I'm just going to try this out. Let's see if those 3 go together. If these 3 go together, perfect. And these 3 go together, I can create my trapezoids out of that. Let's look at the picture. 0, 15. It's right here. 4, 6 is right here. 7, negative 5 is about here. Now, let's just stop right there and say, what kind of trapezoid am I making here? If this was like, let's say, some smooth curve going through, my trapezoid would be almost the same picture, because the height, let's see if I do this right. We're connecting these two together. It's just not, yeah, that is kind of a weird trapezoid. Gonna have to be careful, because this region altogether is got some area that's positive and some area that's negative. And in reality, actually, that's not even there. Let's see what the rest of the picture looks like. At 7, negative 5, I go to 12, negative 10. Still going down. Then at 15, he almost back up. So that curve is going up. And then picking back up there, we go to 20 and up to 8. Curve's still going up. Then 25 up to 20. So here's the hard part in reality. This is all positive area here and positive area here. This is all negative area. So I'm just going to rely on my trapezoids. If you recall, the formula was for each trapezoid. The area of a trapezoid is 1/2 base, which is base over 2, times, height over 2, base 1 plus base 2. And this would be base 1, this would be base 2. That's where it would come from. This distance here is actually the height of that trapezoid. So however long this one is. And so that first trapezoid, the height goes from 0 to 7. 7 minus 0 is 7. 7/2. The first base is f of 0. F of 0. Plus the other height will go to f of 7. F of 7. So I will plug those in just to see what's happening here. 7/2. F of 0 is a 15. F of 7 is a -5. That's how high it is. See, 0 went up to 15. That's that. 7 went down to a -5. So it's just that's the height of it. F of 0 was 15 down to the -5. That's your first trapezoid. The second trapezoid, height over 2, from 7 to 15. 15 minus 7 is 8. 8 over 2. Base 1, which is the base 2 of the first one. So that's f of 7. You should see a repeat, and you do, plus f of 15. What does that give me analytically? That gives me a what did I do over here? Oh, 7/2. Did I write this out? Oh, I did write it out. I wrote this wrong place. That's what's bothering me. And I can't remember what that gave me up here. F of 0 was, what happened to my work? Let me go back to this. I think I messed up on some of my writing. That was 7/2. F of 0 was 15. F of 7 was a -5. That became 7/2 times 10. Maybe I just didn't finish it. I thought I did. Okay, back over here. 8/2 is 4. F of 7 is the same answer it was over here, -5. F of 15 is a -2. So that turns into a 4 times a -7. Third trapezoid. The height of the third trapezoid. Did I do the right one? So 7, 15 was 8, yeah. 15 to 25, that's 10. 10/2. Then I'm using the f of 15 is the first piece, which was the last piece of the last one. Always works out that way. And then f of 25, which is a 5. F of 15 was a -2, I believe. And then f of 25 is a +20. Plus 5 times an 18. Wow. Okay, 7, I wasn't going to do all of these, and here I am. 7 halves times 10 is 70 over 2, which is 35. Plus a negative 28. Plus a 90. 90 plus 35 is 125. Minus 28. That gives me, I believe, a 97 is the final area. Which means there's more positive area above the axis than there was below the axis. That's special. That was estimation again, so I don't remember those. And, you know, if you needed more time to finish up the homework, but nobody asked any questions. Did I? Oh, I didn't do your homework. These are your homework problems that you had. If you ask me questions, I'll do a separate lesson on these homework problems. So I'm just going to assume you were figuring. I just do. Speaking of homework problems, submitting it out. If not, let me know. If you're on the right track. Oh, wait a minute. This is notes. This ain't homework. Wait a minute. What is with the PDF document is so much better than pictures of each thing because it connects it really well if it's one PDF. Try to figure that out, how you get that done. But I did grade your test, even with some pictures and just a couple things. Make sure that the orientation is the way you look at it. If you rotate it, I can't rotate it. If I turn my iPad, it rotates. If it's on my computer, I have to stand on my head to see it. So, all right. Next lesson. The Fundamental Theorem of Calculus Part 1, which she means it's the first. And how, it's probably just the definition that I gave you. That the integral of f of x dx from a to b is the antiderivative of b, antiderivative of f of b minus the antiderivative of f. Remember, f of x is the antiderivative of small f of x. So antiderivative substituted in b minus antiderivative substituted in a. Of course, this is given f of x is continuous on the interval AB. Okay. Consider the function. That's just a line, negative 2x plus 3. There it is, beautiful. Calculate the following integrals based on the fundamental theorem of calculus. Well, there's my line, 2x plus 3. So equals the antiderivative. Let me draw the picture from negative 2 to 1. The bottom number usually is smaller. Negative 2 takes me up to here. 1 takes me to here. Before I even do the work, this picture stands out as a beautiful example of a trapezoid. I can approximate that answer with a trapezoid. In this case, my approximation may be perfect. Area is approximately my height of the trapezoid, that's this number right here, from the negative 2 to the 1, okay, negative 2 to 1, that height is, take a negative 2 and subtract a 1, that's a negative 3. So that height here is 3. Just count it too. 1, 2, 3. 3 over 2. Base 1 is this height right here, base 1, and base 2 will be this height here. The height of base 1 goes all the way up to 7 based on the picture. The height at 1 goes all the way up to 1 based on the picture. 3 halves times 8, 24 halves, 12. That's my estimation based on geometry. Let's do it with calculus. The actual answer. Antiderivative of negative 2x is a negative 2x squared over 2 plus a 3x. All that goes from negative 2 to 1. That cancels. Always write out this. Always write out 2 sets of parentheses with a minus in the middle. Plug in the top number, the 1. Negative 1 squared is 1. Plus 3 times 1 is 3. Plug in the negative 2. Negative of a negative 2 squared is still a negative 4. 3 times a negative 2 is a negative 6. Negative 1 plus 3 is 2. Minus negative 4 minus 6 is a negative 10. 2 minus 10 is a 12. And it gave the exact same answer as my geometry did. That's reassuring. Second problem, another line from 2 to 5. 2 goes up to this. 5, so 2 goes to the 1, it looks like. 5 goes to, it looks like 5 is going down to the negative 7 right here. Another trapezoid. The height, 1, 2, 3. That's the height of the trapezoid. Base 1, doesn't matter which is. That one's 1. This one is 7. If I was a betting man, and I'm not, area would be approximately by base 3 divided by 2, 1, negative 1, I'm sorry, plus a negative 7. Those are negative numbers. Negative 7. 3 halves times a negative 8, negative 24 over 2, negative 12. Does it make sense that the area is all negative? Sure. It's all underneath the axis. I'm not surprised at all. Negative area just tells you where it is, below the x-axis or above. So if I integrate this, is equal to, and it's not approximate, this is the actual answer. Negative 2x squared over 2 is a negative x squared plus 3x. All of that goes from 2 to 5. Plug in the 5 after you do this. Make sure you do this. It's just a good trick. Negative 25 plus 15 minus negative 4 plus 12. That's negative 10 minus an 8. That's negative 10 with negative. I need the same answer. This might be my first mistake of the day. Let's see. Negative x squared. Oh, I see what I did wrong. It was, no, I didn't do it wrong. 3x. 3x. You plug it in, negative 25 plus 15, negative 4 plus 12, negative 10 minus, 6. Where did I get the 12? That's a 2. Oh, thank goodness. All right. So I don't think I'll be getting a whole lot of ding, ding, ding on my remind. Negative 10 minus 2 is a negative 12. Exact answer. Same thing. Make sure what the direction was. Consider the below. Calculate each of the following definite. Okay, I guess he did want us to see. This one I had all positive area. This one I had all negative. What are these homework problems? Just to see. Another line. This is getting kind of boring. Do I want to keep doing them? They're all lines. They all look the same. I'm not going to finish those 3. It's the same. Negative 1, 2, 4. Negative 1, 2, 4. This is interesting. That's positive area. That's negative area. They look very close to the same. Let's do the geometry. This area will be base, 1/2 of the base, which is negative 3 minus, oh, that's a good question. I don't know how much that is. I'd have to do the x-intercept to find out exactly that amount. Oh, I don't want to do algebra. X-intercept is when the y is 0. Negative 2x plus 3. That's minus 3 divided by 3/2. That's the x-intercept. Okay. So this is 1.5. 3/2 is that distance. 1/2 times 3/2. That's my base. The height goes all the way up. And I don't think it goes up to the 5. So I got to plug in the negative 1 into the line here and see when x is a negative 1, negative 2 times negative 1 plus 3 is 2 plus 3. Well, it is 5. Huh, doesn't look like it in the graph. Well, I guess it does. I'm just blind. Okay, 5, which is 10/2. So 1 times 3 times 10 is 30 over 8. That's positive. This one, the base is 1 to 2.5, or 5/2. And it goes 1, 2, 3, 4, negative 5. Negative 5. So it's 5/2. So it's 1/2 times 5/2 times negative 5. That's negative 25/4. Okay. This is not coming out as pretty, so I'm just going to do the calculus. After all that algebra. Integral, again, is still negative x squared plus 3x. All of that now from negative 1, 2, 4. I'm going to say they're going to come out pretty close. Negative 25/4 is negative 6 1/4. 30 over 8 is not quite 4. So I think there's more negative. It's probably what you're going to find out. Always set up for that way you don't forget this. Plug in the 4, it's a negative 16 plus a 12. Plug in the negative 1, even though I square it, it's still a negative 1, minus 3. That's negative 14 minus a negative 4. Negative 14 plus 4, negative 10. It is more negative. So go ahead. You do the math. You do this number minus this number and see. Well, that becomes 15/4. Oh, yeah. 15/4. 25/4 minus negative plus 15 fourths is negative 10 fourths. No, that's not coming out exactly to a negative 10. Negative 10. 15 fourths. Yeah, I don't know. Ignore this. I don't know what I was doing wrong. I think the calculus is good. Negative 1 to 3. Negative 1. Still goes to the 5. 3 goes down to the negative 3. It looks like there's more area above, so equals to the negative x squared plus 3x from negative 1 to 3. Open it up, minus, open it up. Plug in the negative 3 first. Negative 9 plus 9. Oh, that's interesting. That's what happened. To plug in the 3, I get a negative 9 plus 9. Plug in the negative 1, I get again, negative 1 minus 3. 0 minus negative 4. 4 is a possibility. You tell me if it's right or wrong. Going from 0 to 5. 0 goes up to 3. 5 goes down to the negative 4. Negative 7, I mean. A lot more area on the bottom. Okay? So that equals to negative x squared plus 3x. Evaluate from 0 to 5. That becomes, plug in the 5, negative 25 plus 15. I love plugging in zeros because look at 0 plus 0. Well, what did I do there? Forgot to put my minus. 0 plus 0. So that just gives me a negative 10 minus 0. That was special. That was your homework. Shall I do a couple? Well, let's see. Based on the results of the 5 previous examples, what inferences can be made about the value of the definite integral and the amount of area bounded by the graph of the integrand with the x-axis? Well, we'll call that net area. If there is more area above the x-axis than below, the net area is negative. Thus, the integral from a to b of f of x is also negative. I'm not going to do the positive. You can, if there is more area, what was this one? This one was above. I can't remember right. That was above. Let me just change that. I can't tell what I wrote. It looked like I was doing below. Is below the x-axis. This one I'm going to do above the x-axis. the, how did I write it there? The area is negative. This area, the area is positive. Thus, the integral from a to b of f of x, the x is also positive. So I said if there is more area below the x-axis than above, that's what I should have done, the area is negative. Thus, the integral is also negative. If there is more area above the x-axis, the area is positive. Thus, the integral is also positive. That's if you're looking at pictures, but usually we're not looking at too many pictures. Find each of the following definite integrals applying the fundamental theorem of calculus. Show your work. Then use your graphing calculator to verify. Oh, I get to show you how to use your graphing calculator. So what I'll do is I'm going to do one problem, then I'll post a couple of the graphing calculator pictures and on it. All right, so I'll do one. So let's integrate from -1 to 2 of 2x minus x squared. That's 2x squared over 2 turns into x squared minus an x cubed over 3 evaluated from a -1 to 2. Two squared minus 2 cubed over 3 minus -1 squared minus a -1 cubed over 3. 4 minus 8/3 minus a 1 minus a -1 cubed. Four is the same thing as 12/3. 12/3 minus 8/3 is 4/3 minus a 1 plus a third is 4/3. Minus 3/3 minus 1/3 is minus. That's another 4/3. That should give us an answer of 0. Now I need to check the calculator, so I'll be right back. Okay, I'm going to grab the picture. It's under, the command is on your calculator, math number 9. Let me show it to you. Math number 9. Now, if you don't have the fancy symbolic and all you get is this with parentheses, then you are not updated. Your calculator is not updated. You have an old one. This is your f of x. This is the, with respect to what? With respect to x, a to b. So your function, x, a, and b separated. This you don't have to put. Ignore that. Okay. Let me get the next picture. When you hit that, oh, that's the wrong picture. I already plugged in the numbers. The -1 to 2 of my function. This is a symbolic view. Let me just put this farther down. I want you to see the other picture, if at all possible. Okay, so now you're looking at it. That's what comes up when you press math number 9. And then you literally have to go up, and you're going to have to take your cursor, and you go, your A goes there, your B goes there, function goes inside, and then you have to put the X. If not, then you have your function f int, and you're going to type in the 2x minus x squared, comma -1, comma 2. Oh, sorry, forgot the x. X, comma -1, comma 2. For the rest of us, we're going to key that in. Okay. Then, when you hit the enter, that's weird, this doesn't want to go on top. Then you hit the enter key. There it is, all keyed in. Let me get the last picture, hopefully with my answer. Okay, there it is. I just uploaded the final answer. And you might think, well, that looks like a big answer, but no, it's really not. It's a trick. It really just means that decimal has to move to the left 17 times. So basically, that is 0. And that's what I had. Okay, let's move on to the rest of the document here. Got to do the rewrite, because we learned that with the antiderivative, all we know is about our power rule. So you have to know your power, and it is a -2 plus an x dx. Okay, so that becomes, add 1 to the -2, that becomes a -1. So it's x to the -1 divided by -1 plus x raised that 1 to a 2 divided by 2. All of that's going from -2 to 3. Rewrite it to make it look prettier. -1 over x plus x squared over 2 from -2 to 3. Plug in the 3. That gives me, get ready for it, a -1/3 plus a 9/2 minus, that's important, don't forget that. When I plug in the -2, it makes that -1 over -2 just a 1/2. When I plug in a -2 and square it, becomes a 4, and negative goes away. 4 over 2 is 2. So it's a 1/2 plus a 2. Now, adding fractions. I'll just do my simple little trick here. 2 times 1 is 2. 3 times 9 is 27. add, oh, that was a negative 2, because there's a negative right here. So that becomes a 25 over 6. 25 over 6 minus, and if you recall, when I plugged in this, it just gave me a 2. A half plus a 2, that's 4, that's 4 halves, that's 5 halves, minus 5 halves, which is really minus 5 halves, the same thing as minus 10 sixths. Get the same denominator. I hope my calculator is going to bear true that the answer is 15 over 6, which reduces to a 5/3. So go ahead, check it with the calculator. If I'm wrong, I'm not going to redo it. I'll just come back with my calculator and say, I'm wrong. Where's the answer? You find it. I'm getting tired, so you find the mistake. So you work on it. Pause the video, as I'm going to. So there's the picture. And just do the math. That's 2/3. This is 3/3. Total of 5/3. Which is what I was looking for. Whoop. 5/3 right there. Okay. Next problem. Make sure you simplify first. The integral from 1 to 4 of a 2x over an x squared plus a 3 over x squared dx. Change them into the powers that I can work with. 2x over x squared is simply 2 over x, which is 2x to the negative 1, plus 3x to the negative 2 dx equals, my antiderivative is going to be add, oh, okay, hold on here. I remember. This is 2 over x, which is 2 times 1 over x. And if you recall, the derivative of a natural log is 1 over x. Because look what happens. Negative 1 plus 1 gives you a 0, divide by 0. Can't do it. That's your clue that this part was 2 times the natural log of x. Okay, trick question. That's a tricky. Now, this one here, plus this is not a problem. This will give me 3x to the negative 1 divided by negative 1. And all of this will be evaluated from a 1 to a 4. So I'll clean that up a bit here. 2 natural log of x minus 3 over x. All of that from 1 to 4. Plug in the 4. 2 natural log of 4, which I don't know, so I just leave it. Minus 3 over 4. All of this, subtract, plug in the 1, 2 natural log of 1, minus 3 over 1 is 2 natural log of 4 minus 3/4. Distribute that negative, but the natural log of 1 is 0, so that's a 0, minus 3 plus 3. So the best answer in its entirety will be 2 natural log of 4 plus 12/4 minus 3/4 is 9/4. I'm going to take that to the bank. Now, go with your calculator, key that in to get the approximate answer, and you do this with your calculator, just the way it's written right there, and see if you agree. I mean, first of all, you got to agree with my work. Trig. Integrate it. That becomes 2x squared over 2. That gives me x squared. Integral of cosine is positive sine from 0 to pi. Plug in the pi first. Pi squared plus sine of pi. Plug in the 0. 0 squared plus sine of 0. That's pi squared. Sine of pi is plus a 0 minus a 0 minus the plus, that's minus sine of 0. Oh, sine of 0 is still 0. So my best answer is pi squared, I believe. I hope so, because I'm tired. Last page, I believe. Picture below is a table of values, represents the values of a function, and its first and second derivatives. Okay. Use the information table to answer. Let's see what happens here. So we don't have a function, but we do know we want the area from -3 to 1 of this function. So we're using this row. Well, they're all f's. One's f prime, one's f double prime. We'll see what happens here. Oh, I'm sorry, this is f prime. That's good to know, because when I take the antiderivative of it, it just gives me f from -3 to 1. So when you take the integral of a derivative, you get the function. So that leaves me with just f plugged in the top, 1, minus f of the bottom. Okay, that's why they gave me the table. F of the top, f of 1 is 0, oh, -2, minus f of 3 is a 1. So -3 should be my answer, unless I made a mistake. Wasn't bad. Use the same table. What is the value of integrate f prime of x plus f double prime of x? Okay, so when you integrate, again, when you integrate the derivative, this gives you f, oh, sorry, what did I do that for? F of x from -1 to 3. Then I'm just splitting this up into two integrals. Plus, when you integrate a second derivative, you get the first derivative from -1 to 3. So f of x from -1 to 3 gives you f of 3 minus f of -1. Add that to f prime of 3 minus f prime of -1. F of 3 was a 1 minus f of a -1 is a 0. Add that to f prime of 3 is 3 minus f prime of a -1, 1. So I have final answer 1 minus 0 plus 3. That's 4. 4 minus 3. Final answer is a 3. Third problem. Integrate from 1 to 5 of 3 of f of x. But you're going to learn that one of the properties of integrals is you can always factor out a constant. So that might make the work a little easier. F double prime of x dx. So that equals to 3 of everything. What's everything? when you integrate the second derivative, you got f prime of x from 1 to 5 turns into 3 of f prime of 5 minus f prime of 1 is 3 times f prime of 5 is 2. F prime of 1 is 0. Hope I'm looking at the right, yeah. Not sure why they gave me the second derivative there. So that's 3 times 2 is 6. Okay, write the equation of the tangent line to f at x is negative 3. Well, tangent line still needs y minus, we're at 3, right? F of 3 is my y1 equals to your slope, which is your f prime at 3, times x minus the 3. I get all those values from the table. Y minus f of 3 again is f of 3 is a 1. I should have memorized it. F prime of 3, I've used that already. F prime of 3 is the 3. Maybe I used it. I don't remember. X minus 3. And I'd just leave that answer. Perfectly good answer. I noticed how on the test some of you wanted to simplify and use the equation of number 5 to approximate the value of f of 3.1. So what's happening here is, again, you are on a curve. We created a tangent line at 3, but he wants me to use that tangent line to approximate 3.1. So remember, we are using this line, which is only touching the function here. 3.1 could actually be here. And the real value is down there, maybe. I don't know yet, because the real value also, I could have drawn the picture this way. The real value could have been up here. But I'm using this line right here. That's where I'm approximating it to be. Now, if there's two different kinds of pictures that it could have been, how am I going to determine which one I use? I'm glad you asked. I'll get to it in a minute. Let's first use this tangent line. Now I am going to solve this for y. Y was going to be 3x minus 9 plus 1 minus 8. Okay, so that's my f of f of x. So f of 3.1 will be approximately, because I'm using this tangent line, 3 times 3.1 minus 8, which is approximately 9.3 minus 8. That answer is 1.3. Now he wants to know, is your answer over or under? Well, it depends. If the curve is red, then it's an under. It's an over. If the curve is blue, then it's an under. Notice the way I drew those pictures? This one's concave down. This is concave up. And how do I know what its concavity is? What was its second derivative at 3? Second derivative at 3 is negative. So, winner, winner, chicken dinner. It's going to be underneath the line. The real answer is underneath the tangent line. So we'll say f of 3.1 is actually less than the approximation of 1.3 because f of x is concave down and the tangent line approximation is above the curve. Beautiful job, if I do say so myself. And there you are. Day 54 homework. It's already posted, and I just got to convert this video. And it's taking me longer this morning because I'm tired. I'm really, really tired.